Okay, so as we just saw in the last video, anytime we are trying to evaluate a limit and we get an indeterminate form, which in this case was 0 over 0, we had to try something else. In the case of your last examples, you were using factoring. Now we're going to look at using the conjugate. Let me explain to you what the conjugate is. The conjugate of two terms, for example, a plus b, is the same two terms with a different sign between it. So the conjugate of a plus b will be a minus b, and the conjugate of a minus b will be a plus b. And the neat thing about the conjugate is if we multiply this conjugate, and regardless of the order here when we do it, so for example, whether I am using here a plus b and a minus b or vice versa, if I were to multiply these together using FOIL, you're going to see that the middle term is going to disappear. A times a will give me a squared. Then I will do a times negative b, that's going to give me a negative ab. A times positive b will give me a positive ab. And then finally b times negative b will give me a negative b squared. So that what you can see happening is when you're using the conjugate, the middle terms go away, and we wind up with something that looks like a squared minus b squared. So we're going to take that concept and we're going to use that to help us to deal with limits where we can't factor them. And specifically, we're going to see this happen with radicals. For example, let's suppose I try to evaluate the limit as x approaches 4 of 4 minus x divided by 2 minus the square root of x. Well, if I were to try a direct substitution, let's look at what that gives us. I'll abbreviate it ds over here. If I were to try a direct substitution, that would give me 4 minus 4, which is 0 on the top, and 2 minus the square root of 4. Remember, we only use the positive if we're taking the square root, so 2 minus 2 will also give me 0. And you've heard them talk about in the video that we call this an indeterminate form, just meaning we cannot determine it. We don't know what it means. It may mean 0, it may not. Matter of fact, you're going to see in this example that it doesn't, may mean 1, may mean 0, may mean a lot of different things. We're going to see in this example that it doesn't equal either of those. So we see here when we look back at our limit that what we get if we try to just do a direct substitution would be an indeterminate form. If I were, to try to, well, can I factor it? That would be my second question, and the answer to that is no, I cannot. I do, however, have a radical with two terms on the bottom. So what I'm going to do is I'm going to come in here and multiply using the conjugate. And I'm going to use the conjugate of this bottom piece because that's where the radical appears. The conjugate of that piece is going to look like 2 plus the square root of x. And if, folks, you have an equation, you are allowed to do anything on one side as long as you do the same thing on the other side. We don't have an equation here, so the only thing we're allowed to do is to multiply by 1. So if I multiply by the bottom using a conjugate, I must do the same thing on the top. Now, let's see what we get when we multiply that. This is going to then equal the limit as x approaches 4. Let's see how this works here. Now, on the top, those things are not conjugates. I don't want you to multiply them. Leave them just as they sit. Never multiply the things that aren't conjugates. There's a reason for this. We're going to wind up being able to do some canceling before it's over with. We're just going to multiply this bottom piece, these two bottom pieces right here, because they are indeed conjugates of each other. 2 times 2 is 4. If I were to do the outer, I would get a positive 2 square root of x, and the inner would give me a negative 2 square root of x. So just like we saw up there, the middle terms in our conjugates cancel out. And then I simply multiply the last. I have a positive times a negative, so that's going to give me a negative. Square root of x times square root of x is simply x. Now at this point, these two things are going to cancel out. I'm going to be left with the limit as x approaches 4 of simply 2 plus the square root of x. And now I can do a direct substitution. That's just going to be 2 plus the square root of 4, which is 2, and 2 plus 2 is 4. So again, we can see here that just because we're getting an indeterminate form of 0 over 0 does not mean it's 1 or 0 or anything else. It means we cannot determine it and that we need to use the conjugate. I want you to notice my notation in this. It's very important. We talked about the fact that math is a language. As I go down the page from the first step here to the second step, notice I have not taken the limit at this point. You don't actually take the limit until you start plugging in the values. So you must continue to use this limit notation. All I'm doing here is multiplying the conjugates of this together. I went ahead and included this next step. It's not necessary. If you want to take the first step that I did and then do your direct substitution from there, that's fine. Once you do a direct substitution, you will eliminate your limit symbol. In my case, I went ahead and put one more step in here. So again, I use the equal sign to indicate the next step. And I continue to use my limit notation because up to this point, I still have yet to actually do that direct substitution. On the next line is where I actually do the direct substitution. I put in 4 for the square root of x. And once I do the direct substitution, I will be allowed then to go ahead and eliminate the limit symbols and go ahead and just do the substitution there. Okay, on this last part, you should be seeing this screen with me. I'm going to kind of go over this so you have some notes here. You can stop this at any point to watch it or to write it. If we are multiplying using the conjugate, the steps we do for doing this are: number 1, multiply using the conjugate of the piece with the radical in it. Only multiply either the top or bottom, whichever ones are the actual conjugates. Never multiply the ones that are not. You want to leave them as they are because once you're done cleaning things up, you should be able to simplify and cross some of that out. And then you will do direct substitution. Always, always remember that you do not want to use the conjugate just because you see a radical. You must try direct substitution first, and I will put some on there where direct substitution is what works. So make sure that you're always trying that first. In addition, make sure that your notation is very clear. Always use your equal signs when you go from one step to the next, and do not eliminate any of your limit symbols until you actually do that direct substitution.